You know, we use numbers every single day, mostly to count things or figure stuff out. But what if there's more to them? What if they have a secret life? A whole world of games, mind-bending puzzles, and just surprising patterns hiding right under our noses. So let's dive in and uncover a few of their secrets. Just imagine for a second that numbers aren't just symbols we write down. What if they're more like characters in a story? With their own personalities, their own little quirks. What if they could play games and create these beautiful patterns all on their own? Well, today, we're going to see just how playful numbers can really be.
So our first puzzle starts with this. Just a simple line of kids. But they're not just standing around. Nope. They're actually speaking a kind of secret code, and it's all made of numbers. Let's see if we can crack it together.
Okay, take a look at this. Every kid has a number. 0, 2, 1, 1, 0, 2, 1, 0. I mean, at first glance, it just looks totally random, right? But there is a very specific, very clever rule that connects these numbers to the kids themselves. Any ideas what it might be? And here it is, the big secret. It's so simple, you're gonna love it. The number each kid says is just how many of their immediate neighbors, the person on their left and the person on their right, are taller than them. That's it. A beautifully simple rule that creates this really cool pattern. Let's see it in action so it really clicks. Look at the second kid from the left. She's saying 2. Why? Well, because the person on her left is taller and the person on her right is also taller. 2 taller neighbors, so she says 2. Simple as that. Now, check out the kid saying 0. That's because he's taller than both of his neighbors. He has exactly 0 taller neighbors. See? Once you know the rule, the whole thing just snaps into place and makes perfect sense. Okay, so now it's your turn. Time to put on your puzzle master hat. If you had 5 kids, all different heights, how would you line them up to create the sequence 0, 1, 2, 1, 0? Really think about it. Who has to be the tallest? Who's got to be the shortest? And where does everyone else fit in? All right, let's take that same idea of neighbors, but let's level up. We're moving from a simple line to a whole grid. And the name of the game here is creating something called supercells. And yeah, there's a strategy to win. So what in the world is supercell? Just think of it like a mountain peak on the grid. It's any number that's bigger than all of its direct neighbors, the numbers above, below, to the left, and to the right. It's basically the king of its little local neighborhood. Now, the real challenge isn't just finding supercells. It's about making as many as you possibly can. So if I gave you a bunch of numbers, how would you arrange them on a grid to get the most supercells? Turns out there's a really clever way to do it. And here's the game plan. It's just 2 easy steps. First, you take all your biggest numbers and you spread them out. Put them in cells that aren't touching each other. Then, step 2, you just fill in all the empty spots with your smallest numbers. By doing that, you're basically building a landscape of peaks and valleys, which guarantees those big numbers will become supercells. Okay, we've had our fun with logic puzzles. Let's switch gears and look at something that's just, well, beautiful. We're going to explore the incredibly satisfying symmetrical world of palindromic numbers. These are numbers with a really unique mirror-like quality. So what is a palindrome? It's just a number that's the same whether you read it forwards or backwards. Like 121 or 848 or even 9009. They're just perfectly symmetrical. And get this, there's a really fun little process you can use to make them yourself. This is something anyone can try. It's super easy. First, just pick any old number. Then you reverse its digits and add that new reverse number to the one you started with. If your answer isn't a palindrome yet, no big deal. You just do the exact same thing again with a new number. Let's do a quick one. Let's start with 34. You reverse it, you get 43. Add them together, 34 plus 43 is 77. And boom, just like that, you've got a palindrome. One step, and we're done. But yeah, it's not always a one-shot deal. Let's try it with 48. Reverse it, you get 84. Add them up, and you get 132. Not a palindrome. So we do it again. Take 132, reverse it to get 231, add those, and we get 363. There it is. Our palindrome. It just took one extra step. This whole reverse and add thing, it seems pretty reliable, doesn't it? I mean, it kind of feels like no matter what number you start with, you're going to hit a palindrome eventually. But what if that's not true? What if there's a number out there, a rebel number, that breaks the rule? Well, say hello to the number 196. This thing is a genuine mathematical mystery. People have used computers to run this reverse and add process millions and millions of times, starting with 196, and it has never turned into a palindrome. Now, nobody's been able to prove that it won't, but nobody has ever found one. It's this amazing, unsolved puzzle just hanging out there in the world of numbers.
Okay, for our grand finale, we are diving into a little bit of pure number magic. This was discovered by the Indian mathematician D.R. Koppelker. It's a process that looks completely random until all of a sudden it isn't.
You can try this right now. Here's what you do. First, pick any 4-digit number you want. The only rule is it has to have at least 2 different digits. Then, rearrange those digits to make the biggest number you can and the smallest number you can, subtract the little one from the big one, and then you just repeat the whole process with your answer. Okay, let's give it a whirl with, say, 8,632. So the biggest number we can make is 8,632. The smallest is 2,368. We subtract the small one from the big one, and our new number is 6,264. Now, we just do the exact same thing again with this new number. All right, round 2, our number is 6,264. The largest arrangement is 6,642. The smallest is 2,466. We do the subtraction, and this time we get 4,176. I mean, it still just feels like we're bouncing around to random numbers, doesn't it? Let's go one more round.
So our new number is 4,176. The biggest we can make from that is 7,641. The smallest is 1,467. We do the subtraction, and the result is 6,174. Wait a second. That number feels kind of familiar. And this is the magic. If you try to do the process again with 6,174, guess what? You just get 6,174 back. Forever. You're stuck in a loop. But here's the truly mind-blowing part. It doesn't matter what 4-digit number you start with. You will almost always end up at this exact number. It's like a mathematical black hole called Koppelker's constant, a hidden point of order in what looks like total chaos.
So, from a simple line of kids telling a story with numbers to a mysterious universal constant, we've seen that numbers are so much more than just tools for math. They're like a playground, full of hidden patterns and puzzles. The secrets are out there. They're just waiting to be found. So, what will you discover next?